All right, let's talk about how to do some molarity calculations. So first, there's four basic types of molarity calculations. There's kind of the basic one where you need to calculate the molarity, and they either give you the moles or the grams and expect you to calculate moles, and they give you the volume. Sometimes it's in milliliters, sometimes it's in liters. So you may need to divide by 1,000 to convert from milliliters to liters. So I highlighted in yellow in this little molarity triangle. You use this by covering up what you want. So take your thumb and put it over the big M. Moles divided by liters gives you molarity. Another type of question that you're asked sometimes is how to calculate how much volume of a solution you need in order to contain a certain number of moles or grams based on the concentration of the solution. So in this case, if you put your thumb over the L, you would do moles divided by molarity, which would give you liters. And sometimes you may need to multiply by 1,000 to convert it back into milliliters. Letter C, the blue one, calculating how many moles or grams of a solute that you need in order to make a certain amount of a certain concentration of a solution. So if you need to know moles, then you would cover that up with your thumb and you would do molarity times liters to determine moles. And then from there, you would multiply by the molar mass to get it into grams. And last but not least, sometimes you need to use the dilution equation to solve for a molarity or to solve for a volume involved with molarities. So you'll calculate for one of the variables, and we'll run through a couple of examples of those as well. So let's start with the A types of molarity calculations. And it starts off pretty simple. What is the molarity, which is moles divided by liters, of a solution that has 4 moles of solute dissolved in 8 liters? Well, 4 divided by 8 is 0.5. So you would just write 0.5 capital M for your final answer, because the capital M is like a shortcut for writing moles per liter. What is the molarity of a solution that has 24 grams of MgCl2 dissolved in 8 liters? So again, we're going to be looking for moles divided by liters, but first we've got to get grams converted into moles. So how much does 1 mole of MgCl2 weigh? We've got to go to the periodic table. Mg is 24.305 and Cl is 35.45. So let me first do 35.45 times 2. That's 70.9 plus 24.305. Answer, 95.205. So if 1 mole weighs 95 grams and we only have 24 grams, we don't even have a full mole. So we've got to divide by that molar mass to convert. 24 divided by 95.205. Answer, 0.25 moles of MgCl2. Now we can calculate the molarity, which is moles divided by liters. So now we know it's 0.25 moles divided by 8 liters. Answer, 0.031 molar MgCl2. What is the molarity of a solution that has 0.5 moles of solute dissolved in 25 milliliters? So this is one where I was saying you want to convert 25 milliliters into liters first. So there are 1,000 milliliters in 1 liter. Multiply across the top, divide by the bottom. That's 0.025 liters. So now we can solve for the molarity. Moles divided by liters. 0.5 moles divided by 0.025 liters equals 5 divided by 0.025, 20 molar. All right, moving on to the B types of molarity calculations next. So if we're solving for liters, we're going to be doing moles divided by molarity. So for the first one, how many liters of a 0.4 molar solution would contain 5 moles of solute? So we're going to do 5 divided by 0.4, and that is 12.5 liters. And the next one we'll end up having to multiply by 1,000 at the end, but we'll do moles divided by molarity to get liters. So it says we've got 0.25 moles divided by our molarity of 2.0. So 0.25 divided by 2, that's 0.125 liters, times by 1,000 equals 125 milliliters. Next, how many liters of a 10 molar solution of NaCl would contain 75 grams of NaCl? Well, in order to get our moles, first we have to convert 75 grams of NaCl into moles. So how much does 1 mole of NaCl weigh? We've got to go to our periodic table. Na is 22.99, Cl is 35.45. That's a molar mass of 58.44. Multiply across the top, divide by the bottom. Answer 1.2, actually I'll just round to 1.3 moles of NaCl. Now, liters is moles divided by molarity. So I'm going to do 1.3 moles divided by 10 molar solution. 1.3 divided by 10, that's 0.13 liters. Now let's practice some C types. So now we're solving for moles. So we're going to do molarity times liters to get moles. So for the first one, how many moles do you need if you've got 3.5 liters of a 0.8 molar solution? So 0.8 moles per liter times 3.5 liters is what? 2.8 moles. Next one, moles is equal to molarity times liters. And this time we've got 300 milliliters. So I need to divide by 1,000 to convert this into liters. My molarity is 7.5 moles per liter times 0.3 liters. How many moles do we need? Typing it in. Answer 2.25 moles. Next, we want to get moles first, and then we'll solve for grams. So we want to make a 3.0 molar solution, and we want to make 0.75 liters of it. So how many moles are we going to need? We're going to need 2.25 moles of HCl. So how many grams is that? Well, how much does 1 mole of HCl weigh? Cl is 35.45. Typing it into my calculator. Plus hydrogen is 1.008. So that's a molar mass of 36.458. Multiplied by moles. Answer, 82 grams of HCl. So that's how much you would add to 0.75 liters to get your 3 molar acid. Last, we've got some dilution questions. So for the first one, it says, how much 5 molar stock solution do you need to make 150 milliliters of a 2 molar solution? Okay, so we've got our equation M1 times V1 equals M2 times V2. Our stock solution is 5 molar. We don't know how much we need, but we know we want to make a 2 molar solution and we want to make 150 milliliters of it. So to get V1 by itself, we're going to divide both sides by the 5 molar. And then I'm going to do 2 times 150 divided by 5. Answer, 60 milliliters. So I would take 60 milliliters of my 5 molar solution and I would put that in my flask and then I would fill to the line, the 150 ml line with water. Doesn't look like enough to be 60. There. This is my 60 milliliters of stock. And then after it's all mixed, when it's diluted with that water, it will only have a volume or a molarity now of 2 molar. Okay, how about this? You've got 300 milliliters of a 7 molar dangerous acid. You add 600 milliliters to dilute it. What's the new concentration? A couple ways you can solve this problem, but I'm going to use the dilution equation since it is getting diluted. It starts with a molarity of 7 molar, and it's 300 milliliters of it. We don't know the new concentration, but we added 600 to the original 300. So the new volume is 900 milliliters. A lot of people miss adding that together. So now I need to divide both sides by 900 to get my new concentration on its own. 7 times 300 divided by 900. Answer is 2.3 molar acid. Last but not least, it says you've got 800 milliliters of a 12 molar acid. You want to dilute it. So you want to add 3.2 liters of water. What's your new concentration? So again, this is a dilution problem. We've got 12 molar acid. We've got 800 milliliters. We don't know the new concentration, but we're adding by times by 1,000. That's 3,200 milliliters to the 800. So that's a total of 4,000 milliliters. So times by 4,000. Divide both sides by 4,000 and we'll have our new concentration. Oops, M2 is what I meant to write here. 12 times 800 divided by 4,000. New concentration is much safer, 2.4 molar. So I know that was a lot of math practice, but the more practice you do with molarity, the better you get and the more it kind of starts to make sense. So good job. Good job.